Hey, this is Charlie, and today I'm going to go over degreeing my cam gears on my 94 3000gt Vr4 motor. A little bit of backstory about the motor. It's an original motor. It's got 66,000 miles on it. At 55,000 miles, I pulled it out. I had it built about 10 years ago by Dave Edgar in Ware, Massachusetts. We basically did the bottom end, forged pistons, rods, upgraded wrist pins, but we kept the head stock. He did rebuild them with new valve stem seals, and he did a mild port and polish on them. But stock cam gears and stock camshafts. Flash forward about 10 years later, the motor's still running great, but I've acquired a few more parts for it. So I pulled it to do that work. I wanted to send my transmission out to get built anyways. So that's out being built, and I'm doing some motor work. So with this motor, I went with 264 BC cams. I've got BC adjustable cam gears. I've did all new timing stuff. That's the OEM water pump, OEM oil pump. In the oil pump is Italio's billet oil pump gear. I've got a solid tensioner there from Arvenge Motorsports. I didn't want to have to worry about the hydraulic tensioner. They have failed before. I've never personally had one fail, but having a solid tensioner will give me a little more peace of mind. This is a Gates Kevlar timing belt. They don't stretch like the OEM ones, which is why you don't really need to worry about going with a solid tensioner. You won't have to constantly adjust it or check it every few months or a few years. Also, the other thing I did is kind of a safety feature is that tensioner pulley right there. The factory one kind of is offset. I actually got it right here. It's got the two little pins and the bolt isn't in the center, and it gets clocked a certain way to put tension on the belt. I'm not running the OEM one. I'm running an OEM one. I think it's for a Kia. It's the exact same size. It looks exactly like it, but the bolt hole is in the center. So if for some reason that ever loosened up, it shouldn't, but if it ever did, it's not going to spin and cause a lot of slack in the belt. So in this video, I'm degreeing the cams. The reason you want to do that is several reasons. Anytime you install aftermarket stuff, there's always kind of tolerances. These are aftermarket gears, aftermarket cams, and aftermarket belt. So stuff may not line up 100%. It may not be 0 degreed when it's on the timing mark. The other thing that can make a difference if the motor's been rebuilt, so some material was probably taken off these heads and block when I had it rebuilt at 55,000 miles. So I want to make sure that I find true 0 on all the cam gears, and that's why it's important to degree it. You need to know kind of where you're starting at if you plan on advancing or retarding your intake exhaust. You want to find true 0. And with the BC cam gears, they recommend running true 0, so that's what I'm going to try to achieve. And I did a bunch of research online about the degreeing process. I watched a few other videos. There's several different ways to do it. There's several different ways to find top dead center. I'll explain all of that, and I'm going to kind of go over what I've found has worked best. I just did my exhaust one, and I'm on my front intake cam right now. So the very first thing that you need to do if you get aftermarket cam gears is make sure they're all set to 0. I've already done that. Even if they look like they're all set to 0, go around with an Allen key and just snug them a little more, because they may feel tight, but they may just be finger tight. You don't want one to spin on you when you're trying to set this. So make sure those are snug. They don't have to be super tight, because you'll be loosening them again, but just not loose enough where they're gonna want to spin. Then get your timing belt set. Make sure all of your timing marks line up. There'll be 2 on each valve cover. I've got this valve cover off, so you're just gonna have to trust me that those line up. And then there's got to be one for your crank gear on the little plate that goes behind the crank gear for the crank sensor. That's got a little notch on it. You could also use your timing cover where it's got the T, and that's just to get us in the right ballpark. So you're going to want to set it to TDC, and then you're going to want to find a spot to attach this wire, and this is just a piece of aluminum welding rod. You're going to want to identify some area where you can put a bolt into something. Here I've got it in the water pump, and then be able to bend that wire where it's easy to get to. So just locate a spot, you can put it in there. Don't worry about bending it in position because you won't know exactly where it needs to go before you get the degree wheel on. And that's the next step. So this is the Summit Racing degree wheel. I'm actually borrowing this from a friend. So I've got that bolted on. I did have to space it out. See if you can see in there. I've got an extra nut in there and a washer just so it won't hit anything. You can see there's a little pin on the end of the crank that would go into the crank pulley. So it needs to be spaced out from that. And you're going to want to make it so that the 0 TDC mark on it kind of goes up to where your pin is. Don't worry if it's not exact, just kind of put it on it where it should be. You're going to be off probably a max of 5 degrees either direction. So just set it there. We're going to find exact TDC after this. And then you're going to want to tighten this. And they say in all the videos online, always go clockwise. And that's the goal. And if you always go clockwise, you have nothing to worry about. But when you're trying to test the degree wheel, and if you go past it a few degrees, you're going to have to crank it all the way around again. And if you use the piston stop to find TDC, which I found is probably the best way to do it, you're going to need to spin this in reverse. So snug it up, and then I took my impact and I put it on it, and I just pulled the trigger for 1 to 2 seconds just to snug it so this wheel isn't going to turn. Make sure you can go back. You don't want it to loosen up if you do have to make it go backwards, because we're going to be spinning it all the way around backwards when we use the piston stop. So at this point, this degree wheel should be on. This should be really tight. You can see I also added a few little marks just to give me a visual to make sure that this degree wheel doesn't spin, because if this spins and loosens up, you're going to have to start all over. So it's very important that that's tight and it's never going to loosen up. Then you can take your wire and you can bend it to where TDC is. And again, this isn't 100% exact. We'll find where it is exactly, but bend it to where TDC is based on all of your marks. And this is going to be a good ballpark. And you can see that I've filed down the end of it to a point, and I've got it pointing at the edge of the wheel. I don't have it extending down in front of it, because if it's in front of it and you kind of look at it from different angles, you may get a different reading. Here it's pointed right at the edge of the wheel. That's what we want. So now we have to find TDC, and there's a few different ways people will do that. One is actually using a dial indicator and using a long extension on it and putting it down the spark plug hole, and then you can kind of watch it to where it maxes out. But you'll find that when it's maxed out, there's like a 1 to 2 to 3 kind of degree difference on this wheel. If you watch it as that piston's coming up, it kind of goes up and then it's got to come back down, but it stays right at the top. It's hard to tell if 1 to 2 degrees before to 1 to 2 degrees after is TDC, because that window when it's at the top, it's kind of got to look at the same height each time. So I tried the dial indicator. I was getting mixed readings. The other thing is when you have a long extension going down through the hole, there could be some wiggle room when it loses contact with the piston, and then the piston comes back up and it makes contact. It may not be in the exact spot on the piston. It may be off just like a thousandth of an inch, and that extender could be tweaked just slightly and give you a different reading. So I didn't like that method. I tried it, I couldn't get an accurate result. I found the best thing to do is actually use a piston stop. So the next thing that you would do is you'd come back here and you'd actually turn this a little ways away from TDC, and then you would use the piston stop, and you can see I've got the end threaded in there, and all it is some threads that match the spark plug thread pattern that get screwed in there, and then inside that collar is the threads for this threaded rod. And you would extend this all the way down, you'd screw it all the way down till it hits the piston, and then you'd back it up like one turn. Then you'd come back over here and you'd crank this back closer to TDC, and you should hit that piston somewhere before you get to the 0 degree mark. Maybe it's around like 12 degrees. And when you do that, record where you're at, so it's at 12 degrees, and then you're going to want to reverse it and crank this all the way around, and then the piston's going to go all the way back down and start coming up again the other way. And then again, it's got to hit this stop, and then you're going to look at the degree wheel, and it should be on the other side of TDC. So if you're plus, let's say you're plus 12 here and minus 12 here, you know right in the middle is 0 TDC. It's probably not going to work out exactly like that. You may be plus 14 over here, and you may be minus 12 over here, and then you just know in the middle is TDC. So you'll have the reading from each side. In the middle is TDC. You'll know you need to spin this 1 degree one way or 2 degrees the other way, whatever, to get it at the 0. Put it back. Take the piston stop out, obviously, but put it back to 0 TDC. And then when it's at 0 TDC, you can grab your wire if it needs to go 1 degree to the right or 1 degree to the left. Bend your wire. Don't try to loosen up this nut and turn the dial, because when you try to tighten it, this may want to spin, and you'll never get this tightened back up as snug as you had with it only advanced 1 or 2 degrees. It's easier just to grab the wire and bend it. That's why we set everything up visually on the timing marks to begin with, just to get this wire in the right ballpark. So we did all that because we knew ahead of time you'd only be bending this like a degree or two one way or the other. After you've got it bent to where it is TDC by the piston stop method, you can repeat the same process, and you should get the exact numbers on each side. It could be plus 12, minus 12, or plus 10, minus 10, coming from each way. If this is in the true center, when you hit the piston stop going each direction, you'll get the same number. And once you have that, do not touch that wire. Don't let your friends in the garage, because if that moves, if this moves or this loosens up, you're gonna have to start over. And this is kind of a painful process, so we don't want to have to do it more than once. So the next step after we've got true TDC is we're gonna go through and use this dial indicator on all the intake and exhaust valves to get everything dialed in. So right here, this is the number 1 cylinder on a 3000 GT. This is the intake valve. I've got this dial indicator set up. I've got a piece of steel bolted here. This is a magnetic base. And you turn that to on, and it activates the magnet. It lowers it inside, I assume, and it sticks. And this is very secure. And these extensions come over, and I've got this dial indicator. And this came with the kit, but these are only about $15 for one at Harbor Freight, which is really accurate. They have a digital one for around $30. And you're going to want to get an extender. And what do I mean by an extender? I don't know if you can see the seam right around here. The gauges don't have a very long extension. This is an extender kit. You can get it off eBay or Amazon. Those will thread in, and it'll give you a longer rod to go down, and you want it to stick on the actual the retainer of the valve, kind of in a flat area, and you want to make sure that this shaft is kind of matching the direction of the spring. You wouldn't want it coming in at a sharp angle this way. You want to make sure that it's not going to hit the lobe when it rotates around. And you want to kind of match the angle. And the same with this angle. You can see it may be leaning slightly, but that amount's fine. You don't want it kinked over way to the side. And just make sure it's away from everything and not going to hit. And this is where you need a solid lifter. So the best thing to do is on the actual valve you'll be working with is get this lobe pointed straight up, and you're going to want to remove the lifter. 3SX has this lifter installed tool they sell. It works really well. I've done it with screwdrivers and masking tape over the end, but this tool is well worth it, especially if you're installing all 99 lifters. But you'll remove the lifter, and then you're going to want to put a solid lifter in its place. And you can see the solid lifter I've already got in there, and it's got a end of it that can be threaded out. And you're going to want to make it so that this rocker arm is sitting on it and there's no tension between it and here. You'll be able to wiggle it around. And then you'll zero out your gauge, and you do that just by kind of turning it to where it's on the 0 mark. And then you're going to want to open up this lifter, so turn it counterclockwise to make it rise up. And you're going to watch this gauge. And as this rises up, it'll eventually get tension on the rocker arm, then you won't be able to wiggle it. And you'll keep going, and you'll see this needle move. And you want it to move 5, I guess it's 0.007 inch, 0.005. So this is just a hair above the 0. So you'd want it just a hair above the 5 mark there. So 5 marks up. And that's preloading the lifter. And that can be a pain to do. You can see there's not a lot of room to get a wrench in here. So what I did is I've got an 8mm wrench here. I had to chop the end of it off so I could get it in there. And I masking taped this wire to it because the last thing I want to do is drop it and have it go down an oil valley. So I use that masking tape, and you can kind of fish it in here from the side, and you'll loosen it, which rises it. You'll put the pressure on there, you preload it, and then after it's preloaded, you'll take this dial and you'll turn it to 0 it again, and then we can start looking at the degree wheel. And what we'll do is the BC cams, pull this here, they do everything with the duration at 0.05 inch. So we're gonna watch this. It's zeroed, and we're gonna crank this over. We're gonna go clockwise. We're gonna go in the direction the motor goes, and we're gonna watch this. And when this needle spins all the way to the 50 mark, that's 0.05. When the lobe is opening the rocker arm, we're going to see what that reading is on the degree wheel. So I've got this, and let's start rotating it. And you want to have your spark plugs out. You don't want it building compression in all the cylinders when you're doing this. The last thing you want to do is have to fight that each rotation. So it hasn't started moving yet. It's starting to. You can see the lobe spinning around. It's just about to make contact. So there, it's starting to turn. And then this can be tricky, and this is why it's good to have the crank pulley bolt tight. So if you do go past it, you can go backwards. And if you do have to go backwards, don't go backwards just a little bit. Go backwards more than you need to, and then go forward again, because if you go backwards, you'll put some slack on the belt here, and this can actually kind of show the same reading in 2 or 3 different degree spots. So if you go backwards, go back further than you need to, and then go forward again. So that is with the intake valve opening. It's at 0.05 inches, and then I'm going to come down here, and I'm going to look at my degree wheel. So here's TDC, and this is cranked past TDC, because if this was to spin clockwise, I've gone past the TDC point on my needle. And I'm about 7 degrees after TDC, so that's a TDC. So I can go back to this camshaft chart, and they've got the intake and exhaust down here. So IO is intake open, so the intake should be opening at 4 degrees after TDC, and mine's opening at 7 degrees after TDC. So I'm gonna have to adjust this, but let's find out when the intake is supposed to close. So the intake's supposed to close 34 degrees after BDC. So that's bottom dead center. That's when the piston is all the way down. And that's on the degree wheel. So there's my TDC, and then BDC is here. So let's go back here, and let's pay attention to this other little dial. So you can see it's between the 5 and the 6. So when that needle gets back to between the 5 and the 6, and the long one is on the 0.05, you need to take a reading. So once that, it's hard to steady everything and turn this precisely. It's easier to have 2 hands on the ratchet to control. So that's pretty close. I'd rather have it right on, but for the purpose of this video, let's go with that. So it's between the 5 and the 6. I'm just about on 50, one degree off, and let's look down here. So here's my bottom dead center. So I've gone past my bottom dead center by 10, 20, 30, 35, 36, 37, 37 and a half degrees. I've already gone through this. There's 37 when I have that exactly on the mark. So that's my after PDC. So it's about 3 degrees off in each direction, which means I'm going to have to adjust this. And I would go through at least 2 rotations on this to check it. And what I like to do is get back to where I started, for that lobe is kind of pointed straight up, and make sure that your gauge is right around 0. If it's reading way off, then this could have slipped, or it could have rubbed on something. So that's what I like to do a full rotation, get my 2 marks, get the lobe pointed back up, make sure I'm at 0, repeat just for consistency, and then I'm going to record that information. And then once you know how far it's off, so this is 3 degrees off, you got to make the adjustments up here. So this mark is zeroed out, and every degree you're off here is half a degree here. So if you're off 3 degrees here, you're going to have to adjust this about 1.5. And there's probably a way to tell if you need to advance or retard it, but in every one I've done, it's always you have to advance it. So I would advance this from 0 to about 1.5, and then I would snug these back up. So when you adjust those, you would take an adjustable wrench, you'd put it on here, secure it with your left hand, you'd loosen these. Once those are loosened, This is probably going to want to spin one way or another. You can keep tension on it with your left hand, and you'll just rotate your left hand to move this to get it to line up where you want, and then snug those Allen keys. And then after you do that, you can repeat the test. And when you repeat the test, you should be even closer, if not dead on the money. Ideally, you'd be 4 TDC and 34 after BDC. It isn't always a perfect world like that. It doesn't always work out exactly. So this front exhaust valve, and I'm actually doing every single cylinder. Really, the majority of people are just going to do the TDC cylinder, sort of a 3000 GT. When that's at TDC, this piston number 1 is at the top, and then piston number 4, which is the middle one in the rear bank, is at the top. So a lot of people will just use this setup going off of those 2 cylinders, but I'm testing every cylinder just so I can get kind of an average, and I did that on the exhaust. And you can see there's some variances. So like the front exhaust, cylinder 5 was 21 before bottom dead center, cylinder 3 was 23, cylinder 1 was 22, and then I was just averaging it. One of the early versions of the BC cams, not anything recent, probably like 10 years ago, one of the cylinders was way off, and that's really the only way someone determined it, was by doing every cylinder. These are supposed to be a lot more precise, and you can see that they really are. All the lobes are pretty close. I'm just doing it for peace of mind. So you don't have to do this. It's good practice. So I'm doing it. I'm doing the average. And then, like I said, it doesn't always work out where it's 3 off one way and 3 off the other way. In my case, I was, I guess, 10 off one way and 7.83 after my average. Call it 8. 10 off one way and 8 off one way on the front. So I kind of split the difference. So 4.5 degrees is what I set it to. So 10 plus 8 divided by 2 is 9, because this has half the, for every 2 degrees of the crank, this is 1. I divided by 2, so that's how I got my 4.5. And you can see I've kind of set that advanced to 4.5. So split the difference if you have to. It's probably not going to be 100% accurate. There are areas where stuff can be off a little, like if this wiggles around or it's not at the precise angle. I'm trusting this degree wheel made by Summit. Hopefully it's accurate. I'm sure it probably is. But going through and doing this process and taking the time to adjust these, you can see this is 4.5 degrees adjustment. It's going to be a hell of a lot closer to being true zero than just slapping them on and making sure these are all zeroed out. So it's worth doing. If you're OCD like me, you can do all of them, or just do cylinders 1 and 4 if you want kind of a quick job at it. And then one last thing I should probably mention, after you're done with this one, obviously you'd move to another camshaft. You're gonna have to remove the solid lifter. You're gonna have to put it down here, and then after you get this one dialed in, you're gonna have to do these as well. You're gonna have to keep moving that solid lifter around. After you're done everything and you've got your wheels set and you've checked them, you should come back and you should double check your TDC mark. Use the stopper. It shouldn't have moved, but you want to make sure this didn't slip, that nothing bumped the needle, and if that shows TDC, then you're good to go. And these are the 0 numbers. It's where BC wants them. But if you're not using BC gears or BC cams and you intend to advance or retard your intake exhaust for more power, go through this process, get them zeroed out where they need to be, Record those numbers, write them down on a piece of paper, put them in your owner's manual, email them to yourself. You don't want to lose them. You could even write them on the cam gears, I guess, with a permanent marker if you want. That way, if something slips or you make an adjustment and you need to go back to where you were, you'll know what the 0 point is. You don't want to lose that. You don't want to have to do this again. It's easier to do this with the engines out of the car. People have done it with the engine in the car, but it's a pain. And if you are going to go through and do all the cylinders and average them, like I'm doing, you don't have to set this for TDC for each cylinder. Keep this wheel on and tight exactly where it is. You're just going to have to look at the degree wheel and realize that I'm not on cylinder 1 anymore. I'm on cylinder 3 or 5, and what's TDC isn't going to be here. It's going to be 120 degrees from here, or it's going to be another 120 degrees, which is 120 degrees this way as TDC. So you can keep the dial right where it is. You just need to make a mental note that don't look at 0 TDC, look 120 degrees this way, and that's the TDC for that cylinder. Same with BDC as well. So everything is finally finished. I tested every cylinder. I guess I didn't test each lobe per cylinder. I just chose one of them, whatever is easier to get the dial indicator on. I thought I'd show this final test. I've got my stopper in and turned one way. It's 11 degrees on this side of TDC. Can't go anymore. And if I crank it all the way around, it's building a little bit of compression because you got the stopper in, so it doesn't turn quite as easy. So there it's stopped, and that's right on 11 degrees. So 11 on each side puts TDC right in the middle at 0. That's what you want. You want it to read the exact same value going each way. So I'll remove my stopper, and I still got to remove that thing that's inside. Let me just go over here real quick to the actual final numbers. I've got everything dialed in, and I did an average of every cylinder, and I took those numbers, so 21, 23, and 22. The average is 22. That's before bottom dead center, and I did the same for when the valve would close, and I took the average, and then I took those average numbers and I compared them to what they're supposed to be. So here's the exhaust, 22 before bottom dead center. Well, it's supposed to be 32 before bottom dead center, so that's 10 degrees off. So here is my 10 degrees, and the other one, the average was 3.83 after TDC, and it's supposed to be 2 degrees before TDC. So you got your, I'm sorry, it's 5.83. That's a 5, not a 3. But 5.83 degrees after TDC, which is the average of 6, 6, and 5.5, 5.83, and it's supposed to be 2 degrees before TDC. So I'm going to take that 5.83, that's after TDC, and I got to add the 2 degrees to it, and that's where I get my 7.83 degrees. So one side's off by 10 for the opening, the closing's off by 7.83. I'm going to split the difference. So if I take the average of those two numbers, and then I'm going to divide that by 2, because 1 degree difference at the cam is worth 2 at the crank, and that gives me 4.45 degrees that I have to change it for the exhaust, and that's the front exhaust. So if I look, that's my best guess at 4.45 degrees advanced, and you can rotate it again to check it. But what I wanted to show, these cams aren't bad. If you had just done the cylinder, so if you didn't test every cylinder and you're just worried about the TDC cylinders when the crank is lined up on the mark, that'd be cylinder 1, and then the rear would be cylinder 4. And you did that same kind of calculation, we'd have 4.375 compared to 4.45. So that's more or less the same. I'm not going to be able to look at the cam gear and turn it and be able to really set the difference here. So that's close enough. Here it's 1.5 to 1.78. That's also really close. Maybe I could take halfway between the marks and then take halfway between that. I may be able to eyeball it a little closer by doing the average and be a little more exact. Here is 4.625 to 4.7 when you do the average of all of them. So that's the same. And then here it's very close, 2.725 to 2.75. So with these BC cams, at least mine anyways, I'm sure they're all made very much the same. You could probably get away with just doing the number 1 cylinder, the intake and the exhaust, and then the number 4, the intake and the exhaust for the TDC checks. You'd save yourself a lot of time from testing all the other cylinders. So that's it. Hopefully that's been helpful. Let me know if you have any questions.